to talk to us about the autonomous Earth with this kind of weatherman thing going on there, which is very exciting.
The Weather Girls.
Yeah. So I've known James for a long time. He did his MSc in the Evolutionary and Adaptive Systems group at Sussex, and then a PhD in the Centre for Computational Neuroscience and Robotics on kind of pretty simple sort of Daisy World type models of Earth life environment at that point. But he's kind of moved on into some more real science, maybe from that point. He went on to the Max Planck Institute doing a postdoc in the biospheric theory and modeling group, and then to the Institute for Complex Systems Simulation at the University of Southampton. But 3 years ago, he moved to the very exciting new institute, the Global Systems Institute at the University of Exeter, where he is leading on sustainability science teaching research. So he's going to be talking to us today about a book that he's writing on the autonomous Earth and how humans created a planetary civilization beyond their control, which is great A-lifestyle stuff. He's also got another book coming out very soon on, which he tells me is even more depressing, on firestorm and flood, the violence of climate change. We're going to talk about that. But, other very important point to note is that at karaoke, he does a fantastic Frank Sinatra impression, and I'm very sad to say we don't yet have a karaoke session organised for this conference, so maybe that's something to add in, or something to add into the discussion about how we do the conferences coming up. So, James, please take it away.
Okay, I apologise in advance if there are any technological problems. Sometimes the audio might go out of sync, but as long as you can hear me, I guess that's all that's really important, isn't it? If you can't hear me, if you do experience any technical problems, then please just let me know, Alex, and I will try and fix it. I understand that we've got in total about 50 minutes, so hopefully I won't speak for more than 40. Is that all right? Okay, so the autonomous Earth, how humans created a planetary civilization that is beyond their control. What does this mean? Well, I'm going to begin by thinking about, let's go back about 250 years and let's go back to the north of England, where it's in that place at that time we see the increased concentration of manufacturing in factories. We see the increased use of machines to run that manufacturing, and we see the increased use of fossil fuels to power those machines. It's the dawn of the Industrial Revolution. It rapidly spread across the rest of the United Kingdom and then Europe. So as we are today in 2020, we live in a globalized, industrialized civilization where we take for granted that many of the things that we consume in the UK were not built in the UK, they were manufactured in other parts of the world. And we also take for granted that events literally on the other side of the world can have near immediate and long-lasting impacts. If nothing else, the global COVID-19 pandemic has taught us that. So one of the things I'm interested in is looking at this system, looking at this as a phenomenon, as a property, as a planetary scale property, and it's something that we can call the technosphere, and I will try and explain what I mean by that. Before I do that, let me go back and revisit some of the Industrial Revolution, how it has literally transformed humanity. So here we see a visualization of industrialization over the past 200 years. So we're going to start this video at the dawn of, we're kind of halfway through the first part of the Industrial Revolution. It's the start of the 19th century. These different colored circles are different countries. They're color coded according to this map over there. So green is the Americas, blue is Africa, yellow is Europe, Eurasia, and red is Central, Southeast Asia, and Australasia. And the size of the circle corresponds to the size of the population. On this axis here, we can see income. It goes down to about $500 a day, all the way up to about $64,000 a day in today's purchasing power. And over on this axis here, life expectancy, as little as 20 and all the way up to 80. Now, when we start this video, what we're going to see is life expectancy goes up and down an awful lot. It's going up and down because of wars, because of pandemics. We also see quite large changes in income. Entering the 20th century, you can see that the European countries are ahead in terms of income and in terms of life expectancy. But this green circle at the start of the 20th century, well, that's the United States. There's the First World War. Here's the global catastrophe of the recessions. Here's the Great Leap Forward from China. See that great drop in life expectancy as a consequence of central planning and famine. Now, since the 1970s and 80s, we can see this feature of turbocharged capitalism, kind of neoliberalism, in which countries are becoming richer and richer, and the life expectancy of those citizens has been increasing, so that now in 2020, we largely inhabit this top right-hand corner of this kind of phase space. In many developed nations, average income can be over £32,000 and life expectancy can be maybe 70 or 80 years plus. But there is a long tail of blue countries. Many nations in Africa haven't undertaken anything like the same industrialization and development that we have. So this is the usual story of how we try to explain what industrialization and development is for. It's for the empowerment, it's for the enrichment of human beings. Now, that process of industrialization has consumed tremendous amounts of stuff. So here we have a video that goes, here we've got a still that shows global use in material stocks from the start of the 20th century up to about 2010. And you can see the amount of materials has not just increased, but it's increased exponentially. In particular, there's this kind of inflection point around 1950, 1960, when our global industrialized civilization really did take off. Today, we estimate that there's something like 30 trillion metric tons of stuff that humans have moved around the surface of the world in order to build the physical fabric of our civilization. So that's everything from spoons to skyscrapers, from forks, fondue sets, fountains. 30 trillion metric tons that is currently in the stock of our civilization. There's an awful lot more material that we've used and then thrown away in terms of refuse or rubbish. Just as spectacular has been the increase in energy, because in order to move all that material, in order to build all this fabric, to make all this stuff, we need energy. Now this shows that tremendous increase. And again, look at that inflection from about 1950. See how there's a gradual increase from about the 1900s, where most of humanity's energy requirements were satisfied by traditional biomass such as wood or peat, which has been the case for the last 13,000 years at least, until the middle of the 19th century, where we see coal begin to figure. The United Kingdom led the world into the Industrial Revolution, and it was the United Kingdom for many decades, which was the world's largest coal extractor and user. But then the 20th century was the century of oil. It's coal, oil and gas, which today produce over 80% of all of our energy requirements. But what about all these renewables? What about wind, wave and solar? Well, you can see it, it's kind of there right at the top, but it's only a very, very small amount. Today, less than 20% of all energy is produced by non-fossil fuels, and many people are actually surprised to learn that that is the same percentage as they supplied 10 years ago in 2011. But what about the tremendous increase in solar panels and wind turbines? And it's true, there has been an exponential increase in these renewable technologies, but there's also been an equally large increase in the amount of energy that humanity consumes. So the actual fraction that renewables produce today is exactly the same as it was 10 years ago. Now, we have known for about 200 years that if you extract coal, oil and gas, and if you burn it, you are going to liberate carbon dioxide that has been stuck in the Earth's lithosphere for many millions of years, because these are fossil fuels. They were formed tens or hundreds of millions of years ago. They kind of trap sunlight. And as you burn them, you will release carbon dioxide. And we would expect that carbon dioxide to accumulate in the Earth's atmosphere. And indeed, this is what we see. I can demonstrate it like this. So on this axis here, we have points of latitude. So this is the South Pole, there's the equator, and 90 degrees north is the North Pole. And these little dots on this line are research stations, and the research stations are scattered around the world according to this little map up there. The important one, or the interesting one, is this red circle here. That's Mauna Loa. That's a research station on the top of an extinct volcano. And this research station, along with the others, have been monitoring concentrations in carbon dioxide since the late 1950s, since about 1958, which we can see measured in this vertical axis here. Now, when we started back in 1979, Mauna Loa was recording about 336 parts per million of CO2 in the Earth's atmosphere. And you can see as the years tick by, that is increasing. But you can see there's a large annual signal. Sometimes this is called the pump handle video, but you can see research stations in the higher northern latitudes are going up and down a lot. The reason they're going up and down a lot is because if you imagine the Earth, or imagine where the equator is in that map, most of the Earth's land surface is to the north of the equator, which means most of the terrestrial vegetation is to the north of the equator. Therefore, in the northern hemisphere summer, when the trees grow their leaves and the flowers bloom, they suck in carbon dioxide from the Earth's atmosphere. And in the winter, when the trees drop their leaves and the flowers die back and the vegetation die back, they respire that carbon dioxide back into the Earth's atmosphere. So this up and down motion, which you can see over on the right-hand side, that kind of sinusoidal signal, is literally the Earth's biosphere breathing in carbon dioxide and then breathing out carbon dioxide. Now, all things being equal, the amount that it breathes in would be the amount that it breathes out. But you can see over there, since 1980, all things are not equal, and all there is a kind of sinusoidal wiggly line, it's clearly increasing. And the reason it is increasing is because the amount of carbon dioxide that humans are producing is increasing because we are burning more coal, oil, and gas. When this video finishes, I can't remember exactly what year it is, maybe about 2018, concentrations around about 400. They've already passed 415, 416 parts per million, and they are continuing to increase. Certainly, no one here has been alive in which the year previously there was a lower concentration of carbon dioxide. Carbon dioxide concentrations are increasing each year, and that is a very, very robust signal. Now, we can go back before the direct measurements in the 1950s. We can use so-called proxy records, the most important ones being ice cores. If you go to regions in Greenland or Antarctica, you will find kilometers of ice which you bore down into that ice, and you can retrieve ice which was deposited in some instances hundreds of thousands, maybe up to and over 1 million years ago. And in that ice, you will find tiny little bubbles of trapped air which were captured in that ice when that ice was formed over that period. If you analyze the carbon concentration, some other bits of chemistry, you can begin to reconstruct what the Earth's climate was like. And when we do that, we can determine that whilst there have been very large changes in the total concentrations of carbon dioxide and temperature, largely as a consequence of the great glaciations, the ice ages, the glacial maximums and minimums that the Earth system has been in within the last, say, 2.6 million years, the concentrations of carbon dioxide in the Earth's atmosphere are unprecedented for many, many millions of years. And we know that if those concentrations remain even as they are, let alone if they were to increase, we are going to see the global average surface temperature of the Earth increase. Now, of course, the question is, how much is it going to increase? Well, you already know that we've warmed the Earth's surface by about 1.1, 1.2 degrees Celsius since pre-industrial periods, and that's because we have emitted carbon. So this solid black line is the annual cumulative emissions of carbon dioxide measured in billions of tons or gigatons. Where we are in 2020, about here now actually, we are emitting something in the order of about 40 billion tons of carbon dioxide into the Earth's atmosphere every year. In order for us to limit warming to no more than, let's say, 1.5 degrees Celsius, which was what the Paris Agreement established back in 2015, we would need to follow this kind of purple curve. Notice at some point it doesn't just get to zero, but by the middle of this century, we end up with a net negative global emissions situation, a situation which we're going to be needing to withdraw maybe up to 10 billion tons of carbon dioxide from the Earth's atmosphere every year and squirrel it away somewhere. But even if we are going to do that, we need to bend the emissions curve. The sooner we bend that emissions curve, then the less warming we are likely to see by the end of this century. Where we are right now, unfortunately, is not following that curve. Global emissions last year did actually decrease by about 7% as a consequence of the global COVID-19 pandemic. But this year they are rebounding and we're probably going to see 2021 recording the second largest increase in CO2 emissions ever, with the trend probably being that by about 22, 23, we might be seeing record-breaking levels of emissions. So we're not following any of these decarbonisation paths at all. We seem to be continuing down a 3 or maybe even 4 degrees Celsius pathway. Why does that matter? Why is that interesting? Well, The international community back in 2015 said, look, 1.5, we really need to limit it at 1.5. But before that, there was this idea of maybe 2 degrees Celsius was the kind of the safeguard rail. If we were trying to understand what's the difference between 2 degrees Celsius and 4 degrees Celsius, well, the one word answer is civilization. If we manage to pump up concentrations of carbon dioxide in the Earth's atmosphere so that we warm the average temperature of the Earth by 4 degrees Celsius with respect to pre-industrial periods by the end of this century, then our globalized, industrialized civilization will no longer exist in the ways in which we understand it right now. If nothing else, significant regions of the tropics will be literally uninhabitable. You won't be able to live there, let alone grow food. And what is left of humanity will be living in the higher latitudes in Canada, Northern Europe, and maybe even some regions in the peninsula Antarctica, because that region will actually be undergoing a greening process because it will be so much warmer. And what will be left of humanity? Maybe about half of today's current population. So rather than an estimated population of 9 or even 11 billion by the end of this century, we could be looking at a global population of maybe no more than 2.5 or even 3.5. So what do we do about that? Well, one way in which we're hoping to address some of these issues is with science. And that might be complexity science, that might be artificial life. There's a role for everyone in the science community and arguably everybody in society to get involved here, to step up to the plate and try to address this challenge. So what is science? What are science superheroes able to do in this context? Well, one thing they're doing is try to understand how much of an impact are we having and how worried we should be about those kind of impacts. And what's emerged as a very influential framework or concept in which to progress some of this research is the planetary boundaries. And I've been involved sort of tangentially in some of this work, and it's become really important. Now, I'm not going to go and explain all the planetary boundaries. For now, I'll just say that there are 9: climate change, biodiversity, ecosystem integrity, freshwater use, ocean acidification. And these kind of 9 dimensions, we can visualize human impacts coming out from the center. The more of an impact we have, the further we are traveling out from that center. Now, for some, we don't think we're in an immediate cause for any concern. For example, stratospheric ozone depletion. Back in the 1970s and 80s, everyone was freaking out about that because of CFCs and ozone depleting substances. But the 1987 Montreal Protocol put us on the right track, so we have largely eliminated those ozone depleting substances and the ozone layer is beginning to thicken up, it's beginning to heal. Not so with climate change. Climate change is actually entering the range of danger. And if you actually look at biogeochemical flows, the amount of phosphorus and nitrogen that humans use largely for agriculture, we're undertaking a large-scale disruption in the Earth system. And also biospheric integrity, genetic diversity, basically rates of species loss. We seem to be in the middle of the beginning of a mass extinction event that might begin to rival one of the great 5 mass extinction events that we've witnessed over the last 500 million years or so. So this is one way in which science is trying to better understand and provide important knowledge and information to society. And the assumption here is that planetary boundaries, these kind of metrics and indicators, are acting kind of like the dashboard, a dashboard of a very, very complex machine. So here we've got a flight deck. This is a flight deck of Concorde. Doesn't fly anymore. Really bad idea, but it's great while it lasted. And what science is meant to do is provide a coordinates, tell us where we are, and then be able to provide input and advice as to how we can better steer our civilization. How can we better work on the various levers and pulleys and buttons and switches so that we can steer spaceship Earth away from disaster, maybe bank it around some mountains that might be looming out of some clouds. Now, arguably, this is the greatest challenge that humanity has ever faced, but we must not shrink. We must not shirk from this responsibility. We must roll up our sleeves. We must make our way to the flight deck, sit down and be prepared to grab control. Unfortunately, I think when we get to the flight deck, we realize that there's nowhere for us to sit because there are no chairs, because the flight deck hasn't been made for us. What we think of the flight deck, what we think of a series of control systems that we can interact with, are actually part of a planetary scale distributed autonomous control system that, while it might have been built in part by humans, is importantly not for us and maybe importantly beyond our immediate control. Now, this is an idea which I didn't come up with, so don't blame me, but it's an idea which we can trace back to a US scientist, geoscientist, Peter Haff. And he's talking about here now the technosphere, and he defines the technosphere as humans, their artifacts, and links between them. So that goes back to that kind of 30 trillion, metric tons of stuff, but then also the information networks we've built, and then arguably the social, cultural information systems that we've built. It's really a total description of the planetary system. Now, one reason Peter's become quite well known, or the technosphere has become quite now well known, is because Peter's got some quite strident arguments about what understanding the technosphere means with regards to, for example, contemporary sustainability challenges. Because Peter's come to the conclusion that we might be really limited in our ability to steer that spaceship Earth. There's a great paper, Humans and Technology in the Anthropocene, 6 Rules. Now, Peter comes to the conclusion that we might have limited agency on the technosphere for 6 reasons that I'm not going to go into now, and I'm not entirely sure I agree with all of them, but it's a fantastic paper and you should read it because it makes you think about our civilization differently. I think it makes us, or affords us, an important new perspective on the planetary system. Now, it's very related, I think, and in some respects, it's a kind of a natural evolution from the idea of the geosphere and the biosphere. So let's go back about 3.9 billion years ago. What would you need? What kind of theoretical framework, what concepts would you need to understand the Earth system? Why do you need to understand atmospheric, lithospheric, cryospheric, hydrospheric dynamics? You need the kind of the language and machinery of physics. The game significantly changed about 3.8 billion years ago with the emergence and then evolution of life, because life since then has profoundly affected and changed the Earth system, the composition, the chemical composition of the Earth's ocean, the lithosphere, the atmosphere. The very oxygen that we breathe is a consequence of previous biological evolution, and therefore the emergence and evolution of complex differentiated organisms and things like us with big brains. So if you want to understand how the Earth system works with the advent of life, these kind of physics-based processes are insufficient. You need a biosphere concept. Now, similarly, we need a new kind of concept to understand the Earth system today. If aliens were come down from outer space, and maybe those unexplained aerial phenomena that the Pentagon just released are indications of the first visits from extraterrestrials, but if they were taking a rather more standoffish perspective, maybe looking, maybe a few light years away, trying to understand the changes in the dynamics of the Earth's atmosphere, and then maybe trying to understand if they were walking around the Earth and not interacting immediately with humans, what is going on in the Earth system, arguably you would need a new explanatory paradigm, because they would be seeing sudden increases in concentrations of carbon dioxide. Now, that's not a geospheric phenomenon. It's not because there's a volcano or because there's a massive meteor impact. It's not a biospheric one in the case of it's the evolution of some kind of methanogenic bacteria which are going crazy and producing lots of methane and CO2. The only way you can understand the changing the dynamics of the Earth's atmosphere and also the changes in species richness, composition, habitat fragmentation is if you put in that Earth system a species which is producing a planetary scale civilization which is using technology driven by fossil fuels or other energy sources in order to produce planetary scale effects. Now, this is very related to the noosphere. So the reason we've all heard about the geosphere or the biosphere is because of Vladimir Vernadsky. Vernadsky was an important biogeochemist, and he kind of championed the idea of the biosphere. But both Vernadsky and Desjardins had ideas around, well, what would be the next kind of evolution? What would be the next stage of development? And they thought it was the noosphere, the sphere of human thought. In order to understand what the Earth system is doing, you need to include somehow in your models, in your representations, in your theory, in your science, intelligence, consciousness, and the consequence of the technologies and the things that they would do to a planetary scale system. Now, in the technosphere, I think the technosphere captures the noosphere and allows us to produce a holistic, fully integrated picture of the Earth system, which includes geosphere, biosphere, and then the products of our technology. But we can go beyond that because, like Haff, we can then critically inquire what is our relationship to the technosphere. And it's a lot more sophisticated and arguably more concerning or worrying than the notion of a flight deck for humanity or flight deck for the spaceship Earth would have us to suggest. Certainly, in the first instance, we can think about the technosphere as the next major stage, kind of the next major evolutionary transition. Now, often when we think about evolutionary transitions, if you think about up here with abiogenesis, then the ability for high fidelity replication, error correction, the ability to produce more complex differentiated organisms, we often look at that in the context of kind of this flow of information and complexity. The Earth system, in terms of biological systems, are becoming more complex over time. Now, what we're missing with this representation is the other side of the equation, which is the changes that life is having on the Earth system, the changes in which life is changing the energy budget of the Earth system, how it's interacting with the movement of energy and material across the Earth system, actually maybe even within its interior. It's a highly dynamic, coupled, co-evolving system between life and planet. But certainly, I think we can put the technosphere into this kind of major evolutionary trend. Something important has happened to the planet since the advent, certainly of the Industrial Revolution, and maybe even much further back. Now, what does this have to do with our ability to control? Well, one way I would explain it, or I would at least perhaps argue for it, is our agency on this technosphere might be limited. In the first instance, let me give a trivial example. If you want to get from A to B, you don't go as the crow flies. You have to travel across the existing infrastructure. This, for example, is a road. You have to follow the road. Certainly in the United Kingdom, we're not allowed to travel pretty much anywhere because everything's owned by somebody. Now, in the UK, some of these roads are very old. For example, sections of the A37 are probably over 2,000 years old because those sections of road were initially produced or created by the Romans. Now, the substrate might be very different. Previously, it was flagstones or cobbles, and now it's asphalt. But what happened very far in Earth's cultural history can strongly determine what we're going to do or how we behave and operate today. But more generally, if you think about humanity's role in our planetary scale civilization, it feels much more less central. So, for example, here is a time lapse. This is one of the central stations in Tokyo. This is the morning rush hour. And what we see now is humans not resolving as individuals, but if they are individuals, they're almost like individual cells coursing through some kind of circulatory system such that they are being breathed in or inducted into the Tokyo megacity structure or superorganism in the morning. And then at the end of the day, they will be expelled out. And these individuals are bringing energy, they're bringing information, they're bringing resources, they're bringing things for the city. So there's an important kind of explanatory framework or position where we can look at humans within this thing called the technosphere. When we do that, we can think of how essentially the technosphere has absolutely captured us. The adage that we are never more than 3 meals away from chaos is certainly true. I wouldn't last 5 minutes out in the wilds expecting me to hunt or something or gather berries. I'd probably kill myself within an afternoon by trying to eat magic mushrooms or something. But if we go back further, we look at the advent of agriculture. That process of technological capture, that capture by the technosphere, arguably happened when the first agrarian societies formed around 13,000 years ago at the end of the last glacial maximum, when we started to use technologies such as a simple plough, when we started to undertake animal husbandry, we started to augment the power that we're able to produce from our own bodies with the power that we can use from animals. And in doing so, we can increase the amount of food per unit area. We can increase carrying capacities far beyond what would have been then the previous hunter-gatherer subsistence societies. As soon as you've used those kind of technological innovations, you're locked in. And there's, I think, compelling evidence now that the quality of life of people at the start of these agricultural revolutions actually decreased. They had poorer nutrition, they had shorter lives, they had arguably more miserable lives. Rather than just going and hunting, gathering and then just chilling about for the rest of the afternoon, they were compelled to continue to put their labor in order to grow food. But these systems proved incredibly powerful and incredibly successful, and ultimately outcompeted those hunter-gatherer societies because they allowed the accumulation of energy and materials and therefore resources and power within a relatively small section of society. Similarly, we can see many examples where life expectancy and quality of life decreased quite significantly earlier on in the first and then second stages of the Industrial Revolution. But the system itself was able to exert so much more power, was able to exert so much more influence, cultural, economic. In the context of the UK, we can't shrink away from understanding the role of military might and colonialism in the expansion of capitalism, that these systems came to dominate. So these are great examples where what is good for an individual is sometimes not aligned with what is good with the system, which is increasing in influence and power. Now, what does this mean in terms of the future? Well, there's lots of dystopian futures which feature possible figures of technology. So here we have a T-1000, I think. This is from Terminator 2, Cameron's fantastic sequel, one of the very few sequels which is just as good, if not better, than the original. And the dystopian feature here is that machines rise up and decide to basically exterminate humans because they're kind of getting in the way, right? We don't think that's going to happen anytime soon. Something more like this is much more concerning to people. So this is a still, a kind of marketing still from Humans season 3. I haven't seen season 3. I've seen season 1, which is very good. And it tells the story of these synths. Human looking to otherwise extent and purposes, they look human, they act human, but they are smarter, they're cleverer, they don't get tired, they don't get angry, they do all the washing, they do all the housework, they'll do any kind of manual labor, but they're also incredibly smart. You can tell them apart because they make them wear these kind of weird green contact lenses or something. And the series is really interesting because it looks at the societal reaction to these kind of increases of AIs, increases of synthetic organisms, because there's a significant pushback. Already we are seeing increased automation of many of the jobs that previously humans used to do. I mean, just in the context of education, we are at the point where we will have algorithms which can outperform, let's say, my ability to mark a thesis. It might even be quite a complex critical piece, but we can get an algorithm that arguably will do better than me. Doesn't get tired, understand the keywords, we can train it on large data sets. But then we've also got algorithms which can create those same critical essays. So pretty soon we'll have students paying for the creation of critical essays, which universities will pay AIs to then mark those critical essays. So what is the point exactly of education or school? But then beyond that, what is the point of humans? If we are at the point, and I'm not going to talk about singularities, but if we're at the point where we'll be able to automate more and more of what humans have traditionally done with the motivation that we have done these jobs in order to grow economies, therefore grow the size of the technosphere, exactly what is the point of humans in this mix now? What value, what is the purpose of humans regards the ever increasing technosphere? Well, we could look to more inspiration from science fiction. It's not because of some weird dystopian outlined in The Matrix. Again, a fantastic piece of science fiction visionary movie making. The weird thing with The Matrix is somehow this hyper-intelligent system was farming humans and building the Matrix to delude them so they could use them as batteries, but surely they would have to use an awful lot of energy to grow the humans in the first place. So if someone could explain that to me, that's great. But humans are not batteries. Humans are not the energy source. Actually, we're the other end. We are the consumers. So here's a little video that was taken, I think, a couple of years ago. And this shows the Black Friday sales. This is taken in the UK because previous to the global pandemic, the UK was beginning to reproduce some of the scenes that we're witnessing in the United States, where you will see people literally stampede, trample over each other, fight each other in order for them to gain access to a shop where they can buy televisions and electric goods somewhat cheaper than they would otherwise. So the role of humans in the technosphere are not as batteries, they are as consumers. So here's a lovely little riff of some artwork based on another classic piece of science fiction, John Carpenter's They Live, which if you haven't seen, you must do. I think that's back from 1976. Some people say it's got the best fight scene of any movie. It has, so you need to watch it just for that. But in the context of this, you need to watch it because that movie is a wonderful kind of conspiracy theory idea in which lizards from outer space are manipulating humans with subliminal messages such as obey, conform, buy, reproduce, in order that humans continue to grow and develop this civilization, which is for the benefit of these lizards. I don't think alien lizards are manipulating us. I think this is an entirely self-emergent, spontaneous kind of system, but the purpose of humans in that system is to consume. In the absence of our consumption, there would not be the production of goods and services. If there would not be the production of goods and services, then we would not see the dissipation of energy gradients and the consumption of energy, material resources, and the growth of the technosphere. We shouldn't be worried about robots taking our jobs. We should be worried about robots taking our place as shoppers, because if that happens, then you really do struggle to understand what's the point of humans. However, let's just take a step and think, well, humans have been important, and they have been really important in allowing the technosphere to grow. Here's a fantastic metaphor. Here's Jenga. Everyone knows Jenga. It's a great game. What humans have done is literally moved materials and resources and built, sometimes skyscrapers, hundreds of meters up into the sky, but built a system which is defying entropy, which is defying kind of energy dissipation gradients, producing this fantastic order that would otherwise dissipate into chaos. And humans have been absolutely crucial for that, because we can overcome constraints through our big brains, through our opposing fingers and thumbs. We can figure out how to solve a problem of continuing to grow this tower of civilization. And I think the planetary boundaries is a perfect example, because what we're doing in science is better understanding where the boundaries are, is allowing society to get nearer to them. Better understanding the interactions between the boundaries is allowing us to fix one boundary. For example, climate change. How are we doing that? Well, for example, we're seeing a large-scale use of bioenergy. I won't labor on this, but I just need to very briefly explain it. We've got a previously coal-fired power station here. That used to burn dirty coal that would pollute and produce carbon dioxide. So what we'll do instead is we will burn wood pellets in that power station. The wood pellets come from trees which previously grew over there. So we'll chop them down, we'll burn them, and then we will capture the carbon dioxide from the chimney, compress it, and then ship it, pipe it, deep underground into probably depleted oil and gas fields, where it will stay for many, many thousands of years. So we can generate electricity and we can reduce carbon dioxide at the same time. It's a win-win. Already, this has had a disastrous impact on biodiversity. It's accelerating the clear-cutting forests, old growth forests in Europe, in North America, South America, and in Asia. It's been a disaster. One thing this tells us is, I think, when it comes to the growth imperative of the technosphere will be quite happy to pretty much liquidate the entire biosphere in order to maintain its growth. So in that context, what humans are useful idiots. We are able to understand with science where the constraints for the growth of the technosphere are. We can put in places solutions to those constraints, which therefore allow the technosphere to grow. Now, at this point, you may rail against this perspective, just like Howard Beale in the fantastic Network. Was it 1978 or was it 76? Fantastic movie. He becomes a little bit unhinged, but there's this wonderful moment where he calls out, I'm a human being, goddammit, my life has value. We are centrally important to the development of the technosphere. We've built the darn thing, right? How can we just be useful idiots? Yes, okay, I agree. Human beings are very important. We're not just useful idiots. Maybe we're something like a slime mold, right? So slime molds are the kind of the poster organism of complex adaptive system. Everybody loves slime molds, and we know all about slime molds and all the kind of cool things that they do. They are distributed kind of superorganisms. They're comprised of individual, otherwise free-living organisms, which under certain circumstances can join together and do really cool, clever stuff. They can sense their environment. They demonstrate intelligence. And one thing they do, and one thing that's always interested in us, is they self-organize and seem to cooperate in a form of altruism. And they do that as part of their reproductive process. They produce these fruiting bodies. Now, what we could do is we could think about humanity, or Homo sapiens, as kind of part of the fruiting bodies of the technosphere. Now, the things that make the stems here, right, okay, so these things here, these cells are never going to reproduce. They're undertaking a classic piece of altruistic cooperation. They are scaffolding the fruiting buds to be able to increase their height, therefore they'll be more likely to be entrained by the wind and blow their spores away. So are we some kind of component of this fruiting body of the technosphere? And if we are, then where are we going? Well, here, I think we've got some interesting things to learn from somebody like Stuart Kauffman. What we are doing is expanding the size of the technosphere. We're actually going from the actual, what exists, the current configuration and way in which the Earth system moves energy and matter around its surface and within its surface, into what we call the adjacent possible. And we can look at the development of the Earth system, the fully coupled, holistic Earth system, as an increase in this kind of ball, this increase of sphere from the actual into the adjacent possible. So as the actual becomes larger, so the adjacent possible becomes larger, and then the possible, the accessible routes, the accessible pathways into a more complex, higher energy dissipation future. And the role of innovation is absolutely crucial in there. What humans have done, the identification of barriers, the ability for the technosphere to elude or evade those barriers and therefore continue to increase in what we might consider in some respects complexity, although don't ask me how I would measure it, can be quite captured, I think, with Kauffman's notion of this kind of expansion of the Earth system. That's the kind of role that humans have played and seem to be playing in the planetary scale evolution. Okay, so I'm going to finish now with some takeaway messages. One thing I think one conclusion we can draw when we look at this planetary scale perspective is the technosphere may be much, much more resilient than we think. Some people think that we are going to overshoot and collapse, that sometime around the middle or the end of this century, the whole thing is going to fall down, and that's going to be some kind of necessary error correcting system. I think the technosphere itself might be an awful lot more resilient, certainly much more resilient than we would consider to be the danger zone for humanity. 2 degrees, 3, 4 degrees Celsius of warming. We could still see a technological civilization consuming just as much energy and materials, if not more, with a much, much smaller population concentrated in those higher and lower latitude and those higher latitude areas in the north and southern hemisphere. We can understand that by looking at the technosphere as a development stage of the Earth system. Everyone now has heard about the Anthropocene, the idea that humans have become a planetary force, a geological force. But really, that suggests that somehow we're steering it, or that we are in control. But we are components of a planetary scale development. Now, one of the reasons I think this has been hard to spot is because we are so used to very hard, certainly in Western societies, very hard distinction between what we consider to be natural and artificial. A skyscraper is artificial, you know, a pond or a forest is natural. If you take a planetary perspective, then both things are just processes, both things are just phenomena. And our animate matter, our material comes from the Earth, quite literally. We're put into motion by largely sunlight because of the primary production that we use and that we eat. We either eat the things that are growing from the sunlight, or we eat the things that grow from the sunlight. And even our civilization is actually solar powered because it's still largely powered by fossil fuels. We are phenomena and processes and dynamics of an unfolding planetary system. And then the final takeaway is that once we take that perspective, we can realize that the technosphere is not actually for us. It doesn't have our best interests at heart. It doesn't really care about our welfare. For too long, we've been telling ourselves that to increase the size of the technosphere in terms of increasing the amount of energy and materials we consume, and therefore increasing the global size of the economy, is somehow going to directly benefit humanity. Even when we see increasing inequality, even when we see many of the global poor stalling in terms of their abilities to catch up with the ever increasing rich in a much, much smaller number of countries. That begins to make much more sense, I think, when we realize that that process of development that we've been witnessing, supercharged development, and let's say over the last 70 or 80 years, is not necessarily for us. Now, can we escape the technosphere? Can we rein in its most predatory impulses and ensure that we can have a soft landing sometime before the end of this century so that we don't see this more dystopian outcomes? I think we can. How can we learn about that? By reading my new book, which I should have written about 6 months ago, and I'm currently in hiding from my publisher. I've nearly really done it, honestly. Out of Control, How Humanity Built a Civilization Hell-Bent on Destroying Itself. It will explain all this and more. I am actually strangely optimistic for reasons that perhaps you might be able to allude or discuss a little bit in the questions. But for now, I think that's me for time. So all that remains is for me to say, thank you very much, and over to you, Alex.
Brilliant. Thanks, James. So there's loads to talk about there. So I think basically you have to type your questions in the Q&A, and then I can't unmute you as attendees, so I read out the questions. I don't know if you, I think James is not on a device, so he can't see them himself. So
Have a look. Let's see what I can do here. No, that's not going to work.
no, that's
Yeah,
fine.
maybe you should read them out.
I will read them out. So I'm going to start with Anonymous. You suggest that maintaining the technosphere may mean reducing the population to 2 billion people concentrated in the northern hemisphere. Could you be a bit more explicit about what you mean here? Who do you think will be left and who do you think will be cold?
Okay, so what I mean there is if we were, we're currently on course for about 3 degrees Celsius warming by the end of this century, but there's large uncertainties. We could be lucky; it could be 2.5. If we don't really do anything drastic, we could be unlucky; it could be 4. It could even be more. If we were to see 4 degrees Celsius by the end of this century, then there would be large regions of the tropics you can't live there anymore. So there's going to be mass migration. There's going to be a significant reduction in the amount of food that we could produce globally. So in the absence of really quite optimistic technological solutions, which involve pretty much everybody living underground and kind of subterranean hydroponics, there's going to be a rapid breakdown in those kind of societies, a tremendous amount of stress it's going to provide, produce on the other currently industrialized nations in higher latitudes. And just simply when you do the kind of like you do the simple back of the envelope calculations as where, if you imagine there is an environmental niche where we can live in terms of, wet bulb temperatures where it's not lethally hot, and where the environmental niche of the crops that we can grow and maybe, animals that we want, when you do that, it's relatively small bands. And then you can do another simple calculation, which is how many people can that support? And it's about 3 billion people. Obviously, what happens in the interim? What happens when our existing civilization begins to break down? So, I mean, in my more darker moments, I worry less about what climate change is going to do to people, what people are going to do to people as a consequence of climate change. We're already seeing tremendous human suffering. I mean, over 25,000 people have lost their lives attempting to flee North Africa and enter Southern Europe over across the Mediterranean. Absolutely desperate stories. And what's been the response of Europe? Literally put the razor wire up. So there are very scary and kind of dystopian possible futures which largely stem from environmental change stressing and pulling apart the fabric of civilization so that it kind of begins to unpick. That's why you don't see impact assessments go much beyond 4 or 5 degrees Celsius, because what's the point? There's no one around, really.
Thanks, James. So Olaf's got a question here, which it's got two parts. So I'll give you, when is the estimated point in time where the resilience of biosphere and technosphere are equal? And then he says, reformulated, technosphere versus extremophiles, who wins?
Oh, wow. You're always going to put your money on the extremophiles. A lot of what they've been here forever, right? The 3.8 billion years ago, some form of bacterial life formed, and they've been running the show in terms of the large scale biogeochemical cycling. Mass extinction events have come and gone, recorded in the fossil record, which have been calamitous for complex life, but they've just been carrying on, and some of them probably even haven't noticed. They're deep in the Earth's rocks. They'll come out one day. It's like, what have I missed? So certainly, if you're looking at, the entire lifetime of the biosphere, in about 1 billion years' time, the sun is going to become so large, it's going to vaporize the biosphere, so it's going to be game over. But right at the end, there's going to be extremophiles hanging in there, and maybe even making their way to other planets on ejecta, little bits of rock thrown off by meteorite impacts, and they might even outlive the Earth, might outlive even the solar system. So my money's always going to be on the extremophiles.
Okay, well, that's good to know.
If you're an extremophile.
So a question from Steen Rasmussen. So he says, great presentation. Why the focus on physical technologies? Human development is guided by a co-evolution of physical and social technologies. Just as physical technologies, agriculture, the wheel, or computers are tools for transforming matter, energy, or information in pursuit of our goals, social technologies are tools for organizing people in pursuit of our goals. Laws, moral values, and money are social technologies, as are ways of organizing an army, a religion, a government, or retail business. So, what are the role of the social technologies here?
Yeah, that's. I didn't talk about that at all. It's obviously it's crucial. So I've got some slides where I talk about the advent of telecommunications, and really that's just the most visible manifestation of the information networks, which you consider to also could include the cultural evolution. There's nothing more powerful than an idea. Now, certainly, I mean, how can all my what? I'll give you a contemporary example. At the moment, there's a lot of discussion about trying to limit warming to no more than 1.5 degrees Celsius, right? Don't tell anyone, but that's not going to happen, right? It's not going to happen. Now, I'm not allowed to say we will not limit to warming to no more than 1.5 degrees Celsius. I scandalize people when I say that. What I should say is that there are no physical reasons why we cannot limit warming to no more than 1.5 degrees Celsius, but there needs to be sufficient political will in order to produce the changes required, right? Now, if we just look at the cultural or the socio-economic and political aspects, then it seems like political will is this kind of mythical substance that we just need to produce more of in order for us to get, to do the decarbonisation. So we seem to scrabble around for not really having to understanding how those cultural dynamics seem to be working or failing. And of course, a really important component for our explanation of why it's proving so hard is because of the tremendous amount of energy that fossil fuels currently produce. I mean, that's the major challenge. So just to ask for political will is to ask for nothing. I mean, we could say we could end all political violence tomorrow if there was sufficient political will. Everyone just needs to lay down their arms, right? It's there are. So I absolutely agree. There are important cultural information substrate to the technosphere that we absolutely have to include. I suppose my initial starting point is to consider the energetics, and I completely hold my hand up about that. And I'm trying to be open and honest about it in the book.
Okay, that sounds like that could be a big discussion going on. I'm going to put in something from Carlos Gershenson right now. Very pertinent, timely question. Are there any lessons from the current pandemic that might be useful for dealing with climate change?
Yeah, I mean, one thing that people have tried to argue is, you push the Earth system so far, it's going to bite you in the arse. It's gonna give you a kick. It's like poking a bear with a stick. Eventually, you poke it enough, it's gonna respond in certain ways. I mean, our highly connected, globalized civilization meant that the initial outbreak of the pandemic is going to be incredibly hard to control, because it just gets distributed so very, very quickly. But also, I think, it sounds a bit depressing again. I am upbeat, really, but I think, time and time again, let's just talk about the UK because it's kind of timely. It's freedom. We are in freedom. We had Freedom Day. What was it yesterday? 50,000, 40,000 new confirmed cases of COVID. The UK government has demonstrated time and time again it cannot do what's required to slow down the outbreak, control, get a handle on the outbreak, because it's seen as direct opposition with economic growth. That growth imperative, and if we can't even do it when there are literally people dying, this isn't a problem, 50 years into the future. Climate change is sometimes cast as, a problem over the political horizon. We're talking next day, next week, the kind of things that politicians have to do right now. They continually fail to act, and they motivated their failure to act in the context of economic growth. So maybe one important thing we can do is ask, economic growth for who? To what benefit is this? It is true that we've got more than enough resources, that nobody needs to go hungry. We've got more than enough resources to make sure nobody experiences food poverty. Obviously, the problem is the distribution. But we tell ourselves a whole bunch of stories about, well, this distribution is just an emergent property of this very fast-growing economy or something. So maybe one thing the pandemic can ask us to do is to push back about notions of progress and economic growth when they are in direct opposition to clear direct opposition to human well-being and welfare. I mean, if we can't do it now, right, what hope have we got to deal with distant challenges maybe decades down the road?
Okay, thanks, James. I think there's lots more to discuss here. So please, everyone, post stuff in the Slack channel for James to ask, to answer in future, and come and talk about it at the A Life for Good and the A Life in Society special sessions. which are, you know, the most exciting part of the conference. So I'm going to give everyone a little break now, but thank you very much, James. That was really fantastic, and I'm really looking forward to talking to you in some depth about this.
Many thanks, Alex. Well done for your superb chairing today. I think it's amazing the organisation that you and the other folk are putting in. It's incredibly impressive. And thank you so much for the. I am actually able to now to look at the chat. Great questions that I'd like to meditate on a little bit more.
Great, and please, everyone, do put those in the Slack for James. Great, thank you.
Thank you.